Hello everyone, my name is Malika and I will be demonstrating 3 experiments in this video. Let's start with the first one, optical illusions. You can see a bright green screen in front of you. Keep staring at it. Stare it until it vanishes off. As soon as the green screen disappears, you will see a magenta color. Well, this magenta color is because of the white screen. That's sort of a magic, right? But why do we see magenta color? Seeing magenta after looking at a green screen is because our eyes have color receptors for red, green and blue. When you see green and then stop, the absence of the green stimulates a perception of magenta as the brain combines signals from the red and the blue receptors. What actually are optical illusions? They are visual phenomena that trick the brain into perceiving something that does not necessarily match our reality. These illusions exploit the way our eyes and the brains interpret images, often playing with the concepts like perspectives, colors, and patterns. Optical illusions can make static images appear to move, distort shapes and sizes, or create other effects that challenge our normal visual perception. Here are some more optical illusions. Here are 2 tables. Aren't they of different sizes? Let's find it out. Well, it's of the same size. In this image, you can see that A and B are of different colors, where A is darker than the B. Well, it's of the same color. This is the same phenomena but a different picture. B is smaller than A. Well, A is smaller than B. No, but both are of the same size. I need you to keep staring at the center of this spiral. Keep staring. Continue to stare. You might be getting sleepier. Now look at the back of your hand. Come on, find out the grey dots on this checkbox. Doesn't those grey dots vanish when you directly look into it? Is this a rabbit or a duck? Optical illusions are tricks that make you see things differently than they really are. They play with how your eyes and the brain interpret images, often making the static pictures seem like they are moving or distorting shapes. This phenomena is used in artistic expressions. Optical illusions are frequently used in art to create visually engaging and intriguing works. It is used in graphic designs where designers use optical illusion to enhance visual aesthetics in advertisements, packaging, and digital media. Visual psychology. Optical illusions are employed in research and therapy to study how the brain perceives and processes visual information. Let's move on to our next experiment. How static electricity works. For this experiment, we will require some tissue papers, a towel, a PVC pipe, and scissors to cut the tissue paper. Let's begin with the experiment. I have cut the tissue papers into small pieces. I have changed my towel so that I have a rough surface to rub it on the PVC pipe. Let's rub and check it out what happens. Rub it in a single direction. As you can see, the paper is sticking to the pipe. Let's try it one more time. some. This is static electricity. Static electricity can make paper stick to the PVC pipe due to the phenomenon of electrostatic adhesion. When two materials rub against each other, electrons can transfer from one material to another, creating a difference in electric charge. In the case of a PVC pipe and the paper, friction between the materials can lead to the transfer of electrons, which causes one to become positively charged, whereas the other negatively charged. Oppositely charged objects attract each other, and this is the principle behind static electricity, making the paper stick to the PVC pipe. The negatively charged paper is attracted to the positively charged PVC surface, creating enough force to keep the paper adhered to the pipe. This effect is temporary and diminishes as the charges neutralize over the time with other influences. Electrostatic principles are fundamental to the laser printers and photocopies, where static electricity is used to attract and adhere toner particles to paper. Static electricity can be employed in devices like electrostatic testers or air purifiers to attract and capture dust particles, aiding in cleaning surfaces and improving air quality. In the textile industry, static electricity is used in the process like spinning and flocking, and it can also lead to the phenomena like static cling in clothing. Our final experiment is air pressure. For this experiment, all you require is just two things. Yes, only two. One is a water bottle. Yes, and the second is a compass or a pointer, you say. So let's begin with this experiment. All you need to do is have holes on this bottle. Don't make more than 3 holes for a better experiment. I already have these circles provided, and so I will be making only 3 holes, that is 1, 2 and 3, using this pointer. So let's begin. As you can see, I have made 3 holes on this bottle, 1, 2 and 3. Now let's begin with the main experiment. I have filled the bottle with water till the top. Now you can see there is no leakage, but now let's open the cap and look what happens. You'll notice as and when I open the cap of the bottle, the water starts leaking. This phenomena is the interplay of air pressure and the water flow. When the bottle cap is fixed tightly, the air inside the bottle is trapped and cannot escape easily. As a result, there is relatively high pressure inside the bottle. When you loosen the bottle cap, you allow air to escape and the pressure inside the bottle decreases. So if the holes in the bottle are at the bottom, water may start to flow out due to the force of gravity. However, if the holes are higher up, the reduced air pressure inside the bottle prevents water from freely flowing out. In simple terms, the tight cap traps air, creating pressure that prevents water from leaking. When you open the cap, air escapes and the pressure decreases, allowing the water to flow out of the holes. Some beverage containers use a similar principle to control the flow of liquids when pouring or drinking, providing convenience and preventing the spills. Certain sports water bottles have designs that use air pressure to control the rate of water flow, allowing users to hydrate quickly with a simple squeeze or sip. Child-friendly cups with the spouts often incorporate air pressure mechanism to regulate the flow of liquid, making it easier for young children to drink without excessive spills. I hope you all enjoyed this video. Thank you so much for watching.